Part 2 of this video, I'm going to solve some of the problems on the assignment. Right now I'm looking at assignment number 1, problem number 1. So part 1 of the video is where I kind of went over the key skills that you need to have to solve rational equations. We need to focus on having common denominators in our problem. So right now, the expression on the left side of the equation, the denominator is x plus 1. On the right side of the equation, I just have x plus 5. I don't see a denominator, so what I'm going to do is actually turn this into a fraction by dividing it by 1. Okay, and now what I'm going to do is change this denominator to match the x plus 1 that we have here on the left. How do we do that? Well, we're multiplying. So think of lowest common denominators. Lowest common multiples, LCM. 1 times what will give me x plus 1? Because all I want is just for them to match. 1 times x plus 1 gives me x plus 1. And if you multiply something to the denominator, you also have to multiply it to the numerator. So just please don't forget. And I'm going to rewrite this. X squared minus 4 divided by x plus 1 equals, if you look at the numerator here, I have two binomials that are being multiplied. So this is when you have to use the FOIL or the distributive method. So x times x is x squared. X times 1 is positive 1x. 5 times x is positive 5x. 5 times 1 is positive 5. For the denominator, 1 times x plus 1 is just x plus 1. Okay, so if you notice, now I have common denominators. And all you have to do is just focus on the numerator. So I'm going to just rewrite the numerators. X squared minus 4 equals x squared plus x plus 5x plus 5. And I'm going to just start solving for x. I'm going to first combine like terms here. And I'm going to subtract the x squared. So that cancels out here, cancels out here. I'm going to subtract the 5 over. So that way I have constants on one side, variables on the other. This cancels out. Negative 4 minus 5 is negative 9 equals 6x. Divide by 6. X is equal to negative 9 over 6. But this fraction can be simplified, so make sure you always simplify. That's going to be giving me negative 3 over 2. So right now, that is a solution to the problem. So just like part 1, I'm not going to just assume that it is and move on. I'm actually going to check my work by plugging it back to the original problem. So negative 3 over 2. I'm going to plug this value in wherever I see the variable. Okay, so we are dealing with fractions. Negative 3 over 2 squared. So that just means I have negative 3 over 2 multiplying itself twice. Minus 4. The denominator is okay, so I'm just going to rewrite that. And the numerator is okay. All right. So let me deal with the multiplication. When you're multiplying fractions, you just have to multiply straight across. So negative 3 times negative 3 is positive 9. 2 times 2 is 4. So this is actually positive 9 over 4. Okay. Now what I'm going to do is, because the numerator is asking us to subtract, the denominator is asking us to add, this right side expression is asking us to add, so I'm going to create all common denominators. So the 4, just put a 1 underneath, and I need to have the same denominator, so I'm going to turn the 1 into a 4 to match this one by multiplying the 4 to both numerator and denominator. So this is going to be negative 16 over positive 4. So I'm going to change that. So it's negative 16 over 4. Do the same thing to the denominator. Going to put a 1 underneath this one. And I'm going to turn 1 into a 2 so it matches by multiplying 2 to both numerator and denominator. So this is going to be 2 divided by 2. So positive 2 divided by 2. Put a 1 underneath. I'm going to turn this into a 2 so it matches this 2. That's going to be 10 over 2. If you're not sure why I'm doing this, you have to refer back to part 1 of the video where I explained that in order to add and subtract fractions, you have to have common denominators. It's okay to not have, for example, these denominators don't match these ones. It doesn't matter because I'm only going to subtract these two together and I'm only going to add these two together. So as long as the ones that I'm operating on, as long as they're matching, it's fine. So now I'm going to do the math. When you have the same denominator, you don't have to worry about it anymore. You just focus on the numerator. So 9 minus 16 is going to be negative 7. So it's negative 7. You keep the same denominator, so it's negative 7 over 4. Same denominator, so you only focus on the numerator. Negative 3 plus 2 is negative 1. Denominator stays the same, so it's negative 1 over 2. Same denominator means only focus on the numerator. Negative 3 plus 10 is 7. Keep the same denominator, so it's positive 7 over 2. Okay, we're almost there. If you look here, we're actually dividing fractions. So one of the rules was if you're dividing fractions, this is equivalent to the numerator, so the numerator doesn't change. Instead of dividing, it's the same thing as multiplying the reciprocal of this denominator. Reciprocal just means flip the fraction. Nothing happens to the sign, so it stays negative, but instead of 1 over 2, it's 2 over 1. Okay, now we're multiplying, right? When you multiply fractions, just multiply straight across. So negative 7 times negative 2 is positive 14. 4 times 1 is positive 4. So this is actually positive 14 over 4. Okay, so if I look at my result right now, 14 over 4 does not equal 7 over 2. So what happened? If you take a closer look, 14 over 4 can actually be simplified. 14 and 4 have 2 in common. So I'm going to divide 2. So 14 divided by 2 is 7. 4 divided by 2 is 2. So this simplifies to 7 over 2, which works out perfectly. So now that our final statement or result is true, what that means is that the solution that we solved for, this is correct. Right? This is the right solution to this problem. Okay, I hope that helped. Let's move on to another one. I'm looking at number 4 on assignment number 1. So this one right here. Okay. So the key point is to have the common denominators across the entire problem. The best way to see that in a way with a problem that looks as complicated as this one does is to factor everything out. So factoring is when you're breaking things apart. So if you break everything down, you're able to see it a little bit easier. So let's see, x stays the same. The 5x plus 5 can actually factor it out. I can factor out a 5, and I'm left with x plus 1. X plus 2 cannot be factored, so I'm just going to leave it alone. X squared plus 3x plus 2. This is where you use slide divide bottoms up. If you do that correctly, you should get x plus 1 times x plus 2. Okay, so now let's all kind of take a look. This first expression, or this first fraction, has a 5 and x plus 1 in the denominator. The second fraction here has an x plus 2. So they don't have anything in common in the denominator. If I look at this fraction here, it has x plus 1 and x plus 2 in common. So what I'm going to do is just go back and forth and to figure out what's missing and what the fraction has and what it doesn't have. Let's start with the x plus 1. I have an x plus 1 here. I have an x plus 1 here. So if they have that in common, then might as well just include it here in the middle fraction. How? We're just simply going to multiply it. Again, you multiply the top and bottom of the fraction. Okay, so if I do that, then for sure I'll have an x plus 1 in each of the fractions. Now let's check out another one. I have an x plus 2 here. There is an x plus 2 here, but there is no x plus 2 in the first fraction. So I'm going to include the x plus 2. And I'm going to just check again. Okay, so we have x plus 1, x plus 2, x plus 1, x plus 2. We're good. X plus 1, x plus 2. Okay, we're good. But if you notice, there is a 5 in the first denominator. There is no 5 in the second one. There's no 5 in the third one. So we also have to include the 5. I hope this is making sense. You just want the denominators to have the same things, for it to be the same, for it to be common. Now that we have all of these little notes and multiplications, we have to go ahead and multiply them out. So x plus 2 times x, it's x squared plus 2x. For the denominator, I'm not going to multiply all of them out. And the reason being is when I have common denominators across the entire problem, I don't need them anymore. So if I'm not going to use them anymore, there's no point in doing extra work. So all I'm going to do is just write everything down and not multiply them out. I only multiply the numerator because that's what we're going to continue to use. 1 times x plus 1 times 5. That's 5x plus 5. In the denominator, I have the 5. I have the x plus 1. And I have the x plus 2, just like the first fraction here. Okay, plus, we can't forget that because it is asking us to add these two fractions. 1 times 5 is 5. And for the denominator, I have the 5. I have the x plus 1. And I have the x plus 2. So if you noticed, my denominators are the same. So this is when I only look at the numerator. And I'm just going to rewrite that. And you just solve for the variable. Combine like terms. Okay, let's see. I can subtract the 5x. What I'm going to do is actually set this equation equals 0. By setting this equal to 0, what happens is I've created a slide divide bottoms up quadratic expression here. So what does that mean? Well, x squared minus 3x minus 10 can be factored out to x minus 5 times x plus 2. And x plus 2. And I just set each of them equal to 0 and I solve. So one of my solution is x equals 5. And the other solution that I get is x equals negative 2. But it's not guaranteed that these two are actual solutions of this problem. So you do have to go back and check your work. So x equals 5, x equals negative 2. And by plugging them back into the problem, you should be either getting a true statement or a false statement. Let me start with 5. Why not? 5 times 5 is 25, plus 5 is 30. 5 plus 2 is 7. 5 squared is 25, that's 15. So 25 plus 15 is 40, plus 2 is 42. Okay, so if I look at the problem now, it is asking us to add these two, right? So if I'm only focusing on these two fractions, I'm not going to worry about 5 over 30 just yet. Okay, so if I'm going to add, I need them to have the common denominator. So 7 can turn into 42 if you multiply by 6. Okay, so I am going to multiply numerator and denominator. So that's going to be 6 over 42 plus 1 over 42. And now I just add the numerator, so this is 7 over 42. Right? And now I just have to worry about these two. A couple of things that you can do here. What you could have done is multiply both fractions by whatever factor so that they have a common denominator. You could have. It's okay if the numbers get big. I mean, it's still a number that you can work with, so don't be afraid to use big numbers. So what I mean by that is you could have multiplied this fraction by 42. You could have multiplied this by 30, so that way you get a common denominator. What I'm actually going to do is divide, just so the fractions get smaller. I'm going to divide 5 and 30 by 5. And that's going to give me 1 over 6. And for this one, I'm going to divide by 7. And that's also going to give me 1 over 6, which checks out. So if it checks out, what that means is this solution here that we got, x equals 5, is a true solution. So we're safe with x equals 5, but we're not sure about x equals negative 2 yet. Negative 2's. Okay, let's see. 5 times negative 2 is negative 10. Negative 10 plus 5 is negative 5. Negative 2 plus 2 is 0. Negative 2 squared is positive 4. 3 times negative 2 is negative 6. 4 plus a negative 6 is negative 2. Negative 2 plus positive 2 is 0. The moment you have 0 in the denominator, it becomes undefined. You cannot divide by 0. So when you get an undefined result, it just means it doesn't work. It doesn't exist. So our solution x equals -2, right? That's the one that we plugged in to check. This will be considered our extraneous solution, which basically means false answer. That's how I like to remember it. So extraneous solutions are false answers. And what I mean by that is when we solve the problem initially, clearly we got x equals -2 out of it, right? So it is an answer. But when I plug it back in to check my work, it comes out undefined. It's not working. So even though it's the answer that we got, it doesn't work. So that's how I like to call it a false answer. So x equals -2 is not a solution that we're going to have. So that doesn't work. Only x equals 5. That is the only solution to this problem. All right, so this is number 3 on assignment number 1. Okay. So let's look at our denominators. Again, we want them to be the same. So I like to factor them out just to kind of break everything apart. X squared plus x can be factored out. They have an x in common. All right, here we go. So let's take a look. I have x plus 1 here, I have x plus 1 here, but I do not have x plus 1 here on the third fraction. So I am going to give x plus 1 to 3 over x by multiplying it both top and bottom. And so, okay, we're good. X plus 1, x plus 1, x plus 1. If I look at the second fraction, I have this x here. And on the third fraction, there's also this single x. So I also need to have that in this first fraction by just multiplying that extra x here. So I'm going to double check. I have x plus 1, x times x plus 1, x times x plus 1. So all of my denominators are going to be the same. Let me clean this up. X times 2 is 2x. Again, you don't have to multiply or distribute the denominator. You can. It's not really going to do anything. So I just like to leave it alone. But you can, if you want to do x squared plus x, that's perfectly fine. 3 times x plus 1 is 3x plus 3. And if you notice, all of our denominators are the same. That means I only have to worry about my numerators. So that's 2x minus 1 equals 3x plus 3. And you just solve for x. 2x minus 3x is -1x. I'm going to add the 1 over. Divide by -1 to cancel out the negative. So x is equal to -4. I'm going to check my work. It was x equals -4. All right. So 2 divided by -4 plus 1 is -3 minus 1 divided by -4 squared means -4 times -4. That's +16. +16 plus a -4 is +12. And 3 divided by -4 stays as it is. Okay, so let's look here. It wants us to subtract these two fractions. So I'm only just going to worry about that. If I need to add or subtract fractions, I need the same denominator. Let me actually give this negative to the 2 so I don't have to worry about it. I can turn 3 into a 12 by multiplying 4. So that's going to be -2 times 4 is -8. 3 times 4 is 12. Okay, same denominator, so just worry about the numerator. Negative 8 minus 1 is negative 9. Leave the denominator alone, so this is going to be negative 9 divided by positive 12. Negative 9 divided by positive 12. Okay, but here also, our denominators are not the same. So again, there are a couple of things you could do. You can either multiply or you can divide and simplify the fractions if you can. That's what I'm going to do. The negative sign, it doesn't matter if it's in the numerator or the denominator. It just means that the whole thing is a negative. So whether it's negative 9 divided by 12 or 9 divided by negative 12, it just means the whole fraction is negative. I'm going to divide by 3 because 9 and 12 have 3 in common. So that's going to give me a negative, I'll just put it on the outside, negative 3 over 4. This negative, I'll also put it on the outside, 3 over 4. And they match, they check out. So what that means is this solution here that we saw, 4x equals negative 4, is correct. It is the correct solution to this problem. I really hope this video clarified a lot of the confusions. If you still need help or you're still stuck on a certain problem, please just let us know. Ms. Viramontes and I are here to help you, so please don't hesitate to just reach out to us. Alright, other than that, have a good rest of the day, and I will talk to you guys later. Bye, everybody!